Hey everyone, welcome to a presentation on value-driven cost management through data management. My name is Ross Griffin and I am the founder of a specialist cost and carbon consultancy called Cosmos, as well as a SaaS company, The Fifth Dimension, which is a cost data analytical cloud-based solution. Today we're going to present a project that we worked on. It's a case study. The scope of the presentation will look at the digital strategy from a cost perspective, so 5D if you like, the integrated process of working with the designers in order to be able to harvest information from their process, integrating this in the project, and of course then the result. What does this look like on the back end of the project or the back end of our delivery? I always start our presentations with this quotation, if you like. Value-driven cost management is an integrated collaborative approach to designing to cost, as well as continuous cost follow-up and control. What do I mean by that? We're transitioning away from the traditional model of quantity surveyors and cost managers sitting in the corner or sitting at the back end of a delivery phase, retrospectively looking at information in order to establish what the cost, potential cost of that particular design phase is. We're moving more into an integrated collaborative approach where the cost manager, quantity surveyor is embedded in the project with the design team in order to be able to deliver design to cost solutions, value engineering as an integrated part of the project delivery, not just a cost saving exercise at the back end of a design gateway. But let's get into the project. As I mentioned earlier on, this is a project that we had delivered within Cosmos, working with one of our key clients in the international market. The project, just some key figures for you guys here. It's about 160,000 square meter phase one of a campus project, manufacturing facility. Around 26 buildings in this particular phase. That is 156 unfederated 3D models. And when I mean unfederated, a model for each discipline within the design team and a model for each building. The plot size was about 750,000 square meters and circa 10 different stakeholder groups within the client organization. So quite a large project, I would say, and quite an interesting one from a cost and commercial perspective. How can we do our task, our work, our deliveries as quickly as possible and as efficiently as possible, keeping quality, of course. To give you an idea of the different buildings and areas, you can see that there's approximately 3 buildings that are above 20,000 square meters, 2 at around the 17,000 square meter mark, and then they gradually get smaller after that. So some quite very large buildings in this project, and some quite complex deliverables. So what does this mean for us to delivery strategy? How are we going to approach having to deal with 156 unfederated models, 26 buildings, 160,000 square meter campus, controlling cost, change, preparation of tender estimates and bills of quantities, etc., procuring from the supply chain, as well as, again, efficiency and quality. So our approach with our clients from Cosmos is we prepare what we call the Cosmos roadmap, a commercial management strategy for the project. This outlines what we're going to do at each of the design gateways or each of the phases, what we're going to deliver, how we're going to integrate, communicate, and examples in on the project timeline of the meetings and deliverables we'll have, the milestones, if you like, throughout the project lifecycle. And this, of course, for us includes weekly communication with the design teams, sitting down with each of the disciplines, having micro meetings or stand-ups or whatever you'd like to call them, whatever phraseology you use, but continuous communication with the key representatives, the people who are developing the information. But we need to understand exactly what it is we're going to get from the design team, from the disciplines within the project lifecycle and delivery. So understanding the LOD, the level of detail, and the LOI, the level of information, becomes key to us. Each phase represents different and more detail in terms of information, and we need to understand what we expect to receive, as well as understand what's not included and what we're not going to get during these different stages. For example, detailed MEP design at a LOD 200, for example, schematic base or pre-design. It's not going to be like that. Even though we say LOD 200 at schematic design, the reality is you're not going to get the MEP at that level because it's just not designed. So we need to be clear about what it is that we're receiving and what that level of information looks like. So this matrix is an extract from a BIM execution plan we were working on with the design teams. In this, we're identifying the project parameters, exactly what is we're going to do in terms of takeoff. Will we be able to do quantity takeoff from the models, etc., and what is required for us as cost managers, quantity surveyors, as well as different components to understand what's valuable to us in terms of information during the project delivery. So custom parameters that we need once for our calculations. An example is the capacity of the AHU units, the ventilation units, cubic meters per hour air exchange is important to us. And then what we like to do is give the design teams examples of this information, what exactly it is and what we're looking for, just so that they understand, you know, actually this makes sense now for the cost guys. We can easily add the information or turn on the parameters if it's a case that it's already available. And then who delivers. Again, this is important. Who's delivering this information? A lot of the time we're leaning heavily on the design team to deliver this information because, well, they're preparing it, so it makes sense that we would lean on those guys to use their information, so we're not reinventing the wheel at each design gateway or each stage. So this becomes important for us, and then it's a communication tool so that we can go back and speak to the design team about this. So quite important from our perspective, I would say. And then you talk about information exchange. What exactly does that mean when you talk about 5D or even 6D for that matter, sustainability? What does that mean in terms of the understanding that the design team need to have and the understanding that the cost managers need to have? We developed this kind of short document that we use at the kickoff meetings with our design team. So an example would be in this is the importance of the IFC in terms of information exchange for the 5D process. It's better for us to work in IFC because we can get that opportunity to evaluate the information coming through IFC. Not all information is required. IFC models are generally very heavy. If you export all, for example, all Rivet attributes, then the model becomes huge, and that's not necessary for us as cost specialists. So we like to be able to understand exactly what it is we need and turn off a lot of the parameters that are somewhat automated within Rivet because it's not of interest to us. Understanding the quality of information, the accuracy, of course, and what is not included. I mentioned that before. In the early stages of the design process, there's certain information that will not be designed on drawings or in the model. It might be just descriptive, and it's important for us to understand that as cost specialists. Then we like to talk about different components and elements. So the structure of information, what does that look like for us? What are the type codes we're going to be using on the drawings and in the models, and how is that going to shape how we manage this information and extract this information in the execution. So it's an important document for us, I'd say, because it allows for that communication, and it's kind of like a checklist, you know. We read through it together with the design teams. If they have any questions, they ask us, and we're able to then evaluate what has been included in the BIM execution plan and what is maybe additional information is required. So the challenge for us on this particular project was, as I mentioned earlier on, we had the potential of 156 unfederated models. So we also needed to understand, and when we prepare cost estimates, we like to understand what the cost of each building is. So it's important then again for us to be able to split locations in relation to a number of different attributes, whether it's building type, whether it is the different discipline models. As you can see here, we've identified a number from architecture to structure to electrical to ventilation. And these IFC models become key for us. So 6 different models with 26 different buildings. You have a hell of a lot of information that needs to be structured and needs to be done at the beginning of the project. Otherwise, we will never be able to work with this information. Another challenge for us was working within our own systems. As I mentioned before, it's important for us to divide a project up into building types so that we get a cost for each building, so that the client, investor, customer knows what each building costs them, which building are the major cost drivers. It might not be what they expect, and if they need to then do any changes during the project, it's easy for us to take out a building, take out a proportion, reduce areas, etc., etc. That means that we can respond to our client quite quickly in relation to any questions that they have. So it was important for us to be able to split the 26 buildings. In that sense, we focused on data structure rather than cost estimating. What do I mean by that? ICMS, International Cost Management Standards, is the backbone structure for all cost planning, cost estimating that we do. So we set up a master file in our costing platform or costing system, which is Costex, and use that master file to cost the entire project. But out of that master file, we were able to divide the project up into the 26 buildings. It meant that we were quantifying in one place, we were costing in one place. We didn't have to skip between 26 different buildings. We focused on the entire project, and then as an output, we were able to extract the costs for the 26 buildings in ICMS format. Under ICMS, we were using NRM2 as our method of measurement for quantification. And the majority of information came from the 3D models, which is quite important because it allowed us for much quicker updates through the project life cycle. It allowed us to focus on data quality rather than actual quantification. This sped up the process, which we'll talk about in terms of the results. So quite important. And each model was mapped to the master file, as I mentioned. Here's an example of a HVAC system and MEP. We were just mapping to the models or structures below within Costex. Because we're taking the entire project, once the model mapping is done, it's able to be done quite quickly. The commercial output is all of these different types of documentation, 26 individual buildings, external works, preliminaries, preamble, risks, overhead and profit, options, price lists, etc., etc. All of these documents needed to then be created so that we could procure from the marketplace. And of course, if we could do it all individually, it would have taken us a huge team and quite a lot of additional time to be able to develop this. So the integrated process, as we all kind of know, BIM is here to stay, but BIM is forcing us to interact with the design team. It's also forcing us to interrogate the design information much earlier as it's being developed, as opposed to the back end. This means actually that we need to work together, and the cost manager is part of the design team in reality, because in order to be able to deliver the project on budget or on cost, we need to be able to inform the design team of the direction that they should take. So integrated collaborative approaches is what BIM is actually instigating right now. That integrated approach means that we're speaking to each of the discipline leads on a weekly basis about the project they're designing and developing. So that's not only what they're modeling, but what they're describing, what's on the drawings, the diagrams, all of the schedules, etc. This discussion is also around risks and change, information they'd know because of their conversations they're having with the other stakeholder groups. By having this integrated approach, it means that we're now in a far more informed place. We're much more integrated within the team environment. We're building trust, we're building collaboration, and the design team and disciplines can see us as an ally. The design process is then shifting from our perspective. The traditional model is the QS is on the back end, but what's now happening for us is we're shifting that back end approach to be integrated in the design process, where the QS becomes part of the design team, as we mentioned. This is evolving where we are. Cost plans are created and estimated as design is being developed, because you as the cost manager are now developing data and information that needs to be structured. You can then add and layer more information as the design develops along the project lifecycle. So you're starting day one with your bill of quantity structure in reality, so that you get your back end is just an output of the information you have been structuring through the project lifecycle. The data management, we focused on data rather than estimating. This allowed us to think a little bit differently. We set up rate libraries so that we could streamline the estimating process. The data models, the ICMS format, so that we could have the same structure everywhere. And both of those aligned together are our estimates and tender estimates and cost plans, etc. So by doing it this way, we became much more efficient, and it allowed multiple team members to work on the same project at the same time, which was really efficient. So the result: a manual process, manual measurement, standardizing it, ICMS, digitizing it using the 3D models to quantify, and automation is when you import the model the next time and you have the link created between the quantity and your cost plan, it will automatically update that quantity for you, assuming nothing has changed within the project. So you're getting an awful lot of efficiencies here, reducing repeat work and not having to re-quantify that same element, for example, a foundation, 7 times during the project lifecycle. It's done once for you by the design team when they design it. The result for us was 26 documents, around 6,000 priceable items on our side within that master file, versus 120,000 priceable items if you were to take all 26 buildings individually, having to estimate them individually, etc., etc. We reduced an awful lot of time here. 56 process models, time to update a cost plan around 2 weeks. And remember, this is a 160,000 square meter building campus. It's pretty massive, and we did it with around 5 quantity surveyors, cost managers, not 5 full-time. Actually, it was only 2 full-time, and then 3 were added at the delivery stages when we have model production and estimating review, etc., etc. So quite a large difference there in terms of the priceable items, and here it shows in terms of the number of weeks it took us to deliver our proportion of work. So we extracted the number of weeks for estimating a concept, schematic, and detailed design, the production of the bill of quantity, versus the traditional model would have taken twice as long, because of the manual process, and you would have needed far more cost managers and quantity surveyors to turn around the amount of information you'd need to produce. So we could, in this way of working, be much more efficient, higher quality of information, because you're assessing the design team with the designers, meaning you have a better quality product before it goes to market. So the number of weeks in the overall schedule here saved is quite significant, and obviously time is cost, as we all know. So, and we believe that we'll become even more efficient in the future by doing this. So the conclusion here are 5 key takeaways. Value-driven cost management is an integrated collaborative process. The digital QS needs to be involved from the very beginning. Regular communication is key. Help each other to succeed. Collaboration, collaboration, collaboration. Do not wait until the end of the design is delivered. Work in parallel with the design team. You know, we all need each other to deliver this project successfully. We can't do it in isolation. And quality is everyone's responsibility. Cost is everyone's responsibility. And together, it's achievable. Alone, it's impossible. We have to work together in order to be able to deliver projects successfully. Otherwise, we will continue to fail in delivering these major projects. So thank you very much, everyone, for your time. We're more than happy to chat to anybody about this, about anything relating to digitized cost management or digitized carbon management for that matter. We're very much over LinkedIn, so you'll be able to find us if you have a look here at our LinkedIn pages. Please reach out to us, and we look forward to speaking with you.